Hello class, good day. So in this video, we'll be discussing frequency distribution. We will use this set of data in our problem as our problem for this presentation. So the instruction is to construct a frequency polygon for the following data. In this, we actually have a total of 60 data points. We will use this information as we go through with our computation. First step is to determine the value of k, which is the number of classes for our frequency distribution. So in this scenario, we'll have to use this formula. Again, there are a lot of variations of this formula, but we'll just have to settle on this formula, okay? Now, again, as I have mentioned, n, or the number of data points, is 60, so which means n here will be substituted by 60. On the second step, we'll have already substituted 60 on n, and we'll have to multiply, or we'll have to calculate first the value of the logarithm of 60. Now, in this case, approximately, logarithm of 60 is approximately equal to 1.78. Now, via PEMDAS rules, we'll have to compute first the one with multiplication. So in this scenario, we'll have to multiply first 3.3 times 1.78 before adding the value to 1. In this case, 3.3 times 1.78 is equivalent to 5.87. That is approximately equal because this one has still a lot of decimal values. Adding these two, we'll have approximately 6.87, and if it is to be rounded up to the nearest ones, that will be equivalent to 7. Ibig sabihin, we'll have k equals 7, or we'll have 7 as a number of classes. Step 2 is to determine the range. How to compute for the range? Well, we'll just have to use this formula. Determine the highest value as well as the lowest value and get their difference. With that, that's already, you now have the value of the range. So in this scenario, we do have 29 as the highest value and 10 as the lowest one. That is based on the set of data that is given a while ago. So subtracting these two, we have 19 as the range. That's for step 2. Step 3, obtain the class size. How to compute for the class size? Well, basically, in order to compute for the class size, we'll just have to divide the range by our class interval, so which is also the k. In this scenario, 19 is our range and k, or 7, is our number of class intervals. So in this case, we'll just have to divide these values and round up or round off the given or the result. So in this case, we have 2.71 as the value for C, which is approximately equivalent to 3 if it is to be rounded up to the nearest ones. That is for step 3. Now let us now proceed in constructing the frequency distribution table. So in this case, I already have inputted or actually placed the class limits, but let us just go back to the previous steps that we have a while ago. So in order to construct these class limits, we'll just have to identify the lowest value first, which is in this case is 10. Now, how did I get 12? Now remember, our value for the class size is 3. Ibig sabihin, in order to get the first class interval, by the way, these are our class intervals. This is our first, this is our second, third, and so on and so forth. Okay? So there are all 7 class intervals. In this case, the numbers in between, or what I mean inside each limit or interval, is what we call class size. Now, we do have 10 to 12 here. How did we get that? Well, basically, we'll just have to count starting from the lowest value, 10, then plus 3. That will be 13 minus 1, that is 12. Now, question, why is it minus 1, sir? It is minus 1 basically because if you try to input this, or shall I say separate these values, we actually have 3 terms or 3 numbers in inside this limit, or shall I say in this specific interval. So we do have 10, 11, as well as 12. So this pertains to our class size. Am I clear in that? Hopefully, ano? Let us go directly to the second one. Since we ended on 12 here, we'll have to continue the numbering, or shall I say the counting, shall I say, since we ended in 12, we'll have to begin on 13 in this on the second interval, and add 3, that will be 16, minus 1, that will be 15. If I were to list it down, that will be 13, 14, and 15. The same procedure, or the same, goes to the other intervals until we reach this point wherein we already have 28 as the first class, or the lower boundary, and 30 as the upper one. So if we are to list it down, that will be 28, 29, as well as 30. Again, there are 30, or there are 3, I mean, which is our, there are 3 numbers per interval, which is our class size. That is for the class limits. Now we'll have to proceed on going, or shall I say on doing the tally of our data points. That will be on this part. Now, how to do the tally? Basically, we'll just have to identify the numbers that falls on each interval. So for the first one, we'll just have to identify the first one as well as the second. In order to do that, we'll just have to crush out the numbers that fall inside, or on the given specific limit or interval. So we do have 10 to 12, meaning 11 is already counted. That is 1, 2, we have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, we missed one, 18, I will recount, 1, 2, here there is another 10, that will be 19 all in all. Now let's go to the second interval. We have 13 to 15. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 all in all on the interval 13 to 15. So that's how you do the tally. We just have to crush out the values that falls in each interval. So in this case, we do have now these values, or these frequency, or the number of values that falls under each interval. So we do have 19 for 10 to 12, 11 for 13 to 15, 10 for 16 and 18, 9 for 19 and 21, 5 values, or 5 numbers under 25 to 24, 4 for 25 to 27, and 2 for 28 and 30. You would know if your tally is correct if you have matched the number, or total number of data points. In this case, we have matched the number of total data points, which is 60, meaning our tally is correct. That is for the counting, or doing the tally and the frequency. Next one is to get their percentage. Now in this case, we'll just have to do the simple division of the given frequency by the total number of data points, or the total frequency. In this case, we have 60 as the total, meaning we'll have to divide each value by the total. We'll just have to take the, in this case, the quotient. So we have 19 divided by 60, that's approximately equal to 31.67. 11 divided by 60 is 18.33. 10 divided by 60 is 16.67. 9 divided by 60 is 15. 5 divided by 60 is 8.33. 4 divided by 60 is 6.67. And 2 divided by 60 is 3.33. Now this one is expressed in percentage, meaning that is read as 31.67%, and so on and so forth. All in all, to check also if your percentages are correct, just have to add these values, and if their sum is 100, then your computation is correct. Now, finally, we do have this frequency distribution table as our final output. Again, in this we do have 7 class intervals. We do have the class size as 3, and we also have the total number of data points as 60. So with that said, well, I will assume, or shall I say, I will expect that you already know, or you already are informed as to how to construct a frequency distribution table. That's all.